So what we're going to do this morning is talk about the frequently made mistakes from assignment 2A. And most people did reasonably well. There were a number of common mistakes, though, that I want to talk about so that you can correct them for the next version. And I'll talk in a second about the next version as well. First and foremost, please don't remove the to-do tags. That's what I use to quickly identify which parts of the code to look at, to give you comments. And if you remove them, then it takes a lot longer to figure out where everything is. Let's see. So a couple places you'll need to make lists of stuff, right? Lists to keep track of which tasks to fork or which tasks to join and or which tasks to join. So make sure that you use a list there. Don't use array list or array. And in fact, it's probably not a bad idea to use a linked list as the implementation of the list, because you don't necessarily need to allocate an array list for it. And you don't really need to use an array. So using a list would be just perfectly fine. A couple other things. Make sure that you use the correct syntax for generics. In particular, don't say list of fork join task and then just stop. You need to be able to tell it what the parameterized type of the fork join task will be it integer or image or whatever. And then also, this is just a little tip. You don't need to put this again. You can just use the diamond operator like that. You don't need to, repeat the fork join task. That's redundant. It's not wrong. It just isn't the way that people would write Java code. Let's see. For the grad students, you have to use Java 8 syntax, in particular streams-like syntax for some of this stuff, or Java 8 mechanisms. But you have to make sure you're careful in how you do it. So don't do it like this. This is, I think, too complicated, and I don't even think it's correct. Not even sure really what it does. I'll talk about this more when we get a little bit further into a common mistake I saw a lot of people make. You have to make sure that you keep track of the right count of the number of images that need to be reported back up as the program runs. By the time we get to the final version of the code, you will have much more thorough test cases to test all this stuff with unit tests. I want to give you a chance to get it right through thinking about it first before we just test it and you just kind of blindly follow what the test tells you. So we'll talk more about that in a second. So this code I don't think is correct. I think it's too complicated. A couple other things. Don't use recursive task here. If you use recursive task, it makes it complicated to do certain things in the right order at the right time. So instead of using fork join task, instead of using recursive task, please make sure you use fork join task. 99% of people did that. A few people put recursive task. And also make sure, again, that you use the right type of generic type syntax. Don't just say recursive task. You should say recursive task with the proper generic instantiation of the type, be it integer or image or whatnot. It's not really a big deal. I would recommend using linked lists as opposed to array list. Doesn't really matter all that much. OK, and the reason why you want to use recursive task, the reason you do not want to use recursive task and you want to use fork join task is that allows you to be able to kind of combine the creation of the appropriate object, the forking of the appropriate object, and the adding of the appropriate object all in one place. This code here is what happens if you use recursive task, where you can't do this effectively. And so you'll see what's happening instead is that this code is creating the objects, adding them to the fork join task list, and then running another for each loop to go ahead and fork everything. And that's really sort of overkill. You don't need to have those two loops. You can kind of combine the two things together, so you'll end up creating the object, forking it, and adding it to the fork join task list, or whatever you called it. And you can do that all in one fell swoop. And if you use fork join task, you can do that. If you use recursive task, you can't. Almost everybody got the following wrong in one way or another. So you need to take the result that comes back from task.join, and you need to add that to the running tally of the images on page. just incrementing the images on page by 1 isn't going to be the right answer, because join is going to be giving you back counts that could be greater than 1, because it's going to come back and tell you, for example, these pages that you sort of recursively traversed to download images will come back with counts way bigger than 1. So you need to make sure that you do the right computation there. Almost everybody got that wrong in one way or another. So make sure you think about what's coming back from join and what is the meaning of what's coming back from join. Here's a variant of this problem. This person was, in fact, taking the result of join and assigning it to images on page. However, of course, that doesn't make any sense because it's overwriting whatever value was there before. So you're just going to end up with the last call to join as being the number that is returned from this computation, which is absolutely not the right thing. And again, the unit test that we'll put out a little bit later will do a more thorough checking about that. But you should start to think about it now to make sure you're really understanding what the code is trying to do. Let's see, another thing, this was a common mistake. I'd say about half people got this wrong. So make sure that you only increment the transformed images if you don't get back a null from join. So if join fails, if for some reason you can't transform the image, then you shouldn't increment the transformed image count, because obviously it's didn't transform an image, it didn't work. Okay, so now we're into some of the stuff that the grad students are doing, and it's actually really cool. I'll show you when we're all done with everything in the assignment. I'll show you my solutions, and I'll have a version that uses the Java 7 style programming, which is just for each loops and stuff like that. And then I'll also show you the version I have that uses Java streams, sequential streams. And you'll see that the sequential streams version of all this is super cool. So a bunch of the grad students took a shot at this. Some of you did a good job, but it's a little tricky, and we haven't really gone through streams enough yet to totally thoroughly understand the idioms to use. So let me give you some feedback on this. So, so here's one way of doing things. The person did transform.type.values and then converted that into a stream. That's too complicated. Much more straightforward way just to say mTransforms, which is the object that keeps track of the number of transforms, and that's a list, .stream. So that's a much simpler way of doing this this top level thing is a more effective way of doing stream.of and blah, 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 blah. Then a lot of people did stuff like this. A lot of the grad students did variations of this. They used a for each method, which went through each transform and created the appropriate type of task and forked it. And this is not incorrect per se, but it's not really the right way to do it. And the right way to do it is to use a map.collect pipeline. So you'd say, mTransforms.stream.map, and then you do this kind of stuff in the .map. You'd basically go ahead and create the new object with the right type, and you'd fork it, and so on and so forth. And then you would collect all the results into a list, and that would be what would be stored into the result. So you'll have a list up here that you'll collect into. So you don't have to do some things. I'll show you some other stuff that are variants of that mistake in a second. So much cleaner, much more concise. And then this also is not correct because this code is just sort of blindly joining everything and then checking to see what the size is. But that's not really right because you actually have to take a look at what comes back from join. So this code will sort of work from the point of view of joining, but it won't give you the right result if what you're joining doesn't come back with a non-null result. If it comes back with a null result, you'll have the wrong values when you're all done. So you have to rethink how to do that. Here's another variant of this problem. So if you do this right, you don't need to, sorry, this is a different problem here. You don't need to have a transform array at all here. All you need to do is basically do some stuff down here. You don't need to be adding something to a transform array local variable. That doesn't work. I mean, it's unnecessary. And, oh, by the way, this code is missing something really important, namely a return value. So I'm not even sure how that would have gotten through the compiler because there wouldn't have been, well, I take it back. There was a return null here, but this should not work. I mean, this is not what you want to do. You want to make sure that you return something that's not null from this. So that's incorrect. The point I was going to make before, which isn't shown particularly well from this example, somewhere up here would have been a piece of code that looks something like this: list, fork, join, task, integer, fork, join, tasks equal new linked list, or something like that. Oops. So that's what code would have been here at some point. So what I'm saying is, don't use the for each loop to do this. Instead, use map collect, and then you can get rid of this initialization and simply say m transforms stream dot map dot collect to list, right? So that's the much cleaner way of doing things. It's much cleaner in streams to have a stream that collects the results and uses that to initialize a collection, in this case a list, rather than creating the list, initializing it with like new array list or whatever, and then going ahead and doing for each and adding to it. That side effect based approach just is not the right clean way of doing streams. So make sure that you follow the right model for programming the stream. And then down here, this is just a good example of not really thinking through where the parens go. So this code here is checking to see if you can create a new cached item. And what's happening is it does this, the code really just did nothing in that case. It checked this thing, did nothing, and then called apply transform blindly. So this call is in the wrong place. It should be inside the conditional check. So you only want to be able to apply the transform if, in fact, you're able to get the cached image properly. So make sure that you think through the way in which this code works. And also, you need to make sure you properly return null if you aren't able to get the image or the transform doesn't work, and so on. OK, so those were the most common mistakes. I'd say almost everybody. I think there was one person that had sort of a perfect solution, but everybody else has stuff that can be improved. So I will post this video. You can go back and watch it and improve the various things that we talked about. The next assignment, part B of this program, will require you to fix everything we talked about here. And then we're also going to re-implement a different version where you're going to do recursive decomposition of the processing as opposed to putting everything into a linked list. So if you go back and watch the fork join tasks tutorial, you will see a discussion there about a couple of different ways of doing this. We talk about sort of the linear way of doing things, which is kind of what you did here. And then there's also this kind of recursive way of doing things. So part B will involve the recursive way. And I'll have the skeletons for that out shortly.